In this lesson, we're going to be looking at speed and velocity, the language of motion. So speed refers to how fast an object is moving. Okay, it is a distance covered per unit of time. So distance covered per unit of time. So in this case, you can see the distance covered here is greater by the car per time than with the bike. So we say the car is faster because it covers more distance per second. Pretty straightforward. So speed is distance per time, unit time. Okay, the slash means per. It's how much it's per unit time. So the unit for speed is meters, because that's the unit for distance. Unit for time is seconds, so it's meters per second. You say meters per second. So the per symbol means divided by, and it associates the number of units in the numerator with 1 unit of the denominator. So for the speed of the bike, we would say here 5 meters per second. This means that the bike moves or covers 5 meters for each second. Okay, so that's what per means. Now, so this is speed. If we're in a car, you can see that we have the SI unit for speed is meters per second, but in a car we would see that we have units such as kilometers per hour and miles per hour. Okay, so that's another kind of unit for speed that we're familiar with. But if we're inside a car, the speedometer, the needle would always be moving. It's really, really hard to keep an exact speed for a long time, actually for any time. It's always moving no matter how steady you try to be. And so the speedometer tells us the speed at any instant. Okay, we can also call this instantaneous velocity. Okay, so the velocity at any one instant in time is called the instantaneous velocity. But because it's always changing, we don't want to be, it's almost impossible to calculate the speed at every one instant. So because it's changing, we have to use an average speed formula in order to calculate what the speed is. So let's just use, so the average speed is, the formula is total distance covered divided by total time of travel. Okay, so for example, if a car travels 10 kilometers in 1 hour, stops for an hour, and then drives back 10 kilometers in 30 minutes. Okay, well the total distance here is 20 kilometers, so this is total distance. And the total time is 2.5 hours. Okay, so 20 kilometers divided by 2.5 hours is 8 kilometers per hour. So that would be the average speed during this entire trip. Now, what we need to consider again is the difference between speed and velocity. So we could say that this boat here is traveling at 10 meters per second here, and it's traveling 10 meters per second here. The thing is, these are two different motions. Okay, so what we need to talk about is not only the speed but also the direction as well, because somehow we need to distinguish between these two scenarios. So in order to do that, we need velocity vectors. Okay, so all our motion diagrams will now include velocity vectors. So include velocity vectors in motion diagrams. Okay, so a velocity is, here we can have the same speed, but the velocities are different because they have different directions. Okay, so we have basically a speed and direction is what gives us velocity. Okay, so how do we calculate the velocity? Where instead of distance over time, remember we had displacement gives that is a vector nature of the change in position. So we use displacement over time interval. Okay, so that's going to be delta x in one dimension over delta t. And so Vx, again, this is 1D notation. We don't need the vector sign because we have the specified x value. And for this one, we can choose is x final minus x initial over t final minus t initial. And that's equal to, let's use this one over here and start over here. So we would have 0 minus 40. The final position is 0, initial position is plus 40, divided by final time is 4 seconds, initial times is 0 seconds. So this will give us negative 10 meters per second. Okay, and that makes sense because we're going to the left, so our velocity is negative 10 meters per second. So let's quickly look at a model problem. So a hiker sets out for a 23-kilometer trek along the West Coast Trail. After 4 hours, she checks her GPS and finds that she is 8 kilometers 30 degrees north of west from her starting point. Okay, so let's get a coordinate system here. Sketch something like this. She's 8 kilometers 30 degrees north of west. So she is, that's the position vector. So that's that's 8 kilometers. And this is 30 degrees right here. Okay. Now, of course, she could have walked all kinds of ways to get there. Okay, but that was her final position. So what's the average speed? Well, V average is the total distance over total time. So the total distance is 23 kilometers over total time, which is 4 hours. Okay, and in your calculator you can just go 23 divided by 4 and you get 5.75 kilometers per hour. And what is the average velocity? Well, V average is a displacement over time. Displacement is 8 kilometers over 4 hours. Okay, so this would be 2 kilometers per hour, and the direction would be 30 degrees north of west. So which of these would be more appropriate to describe her trip? Well, because she changed her direction so often, this wouldn't be super useful. This wouldn't tell you anything useful about, you know, her average velocity because she's changed direction so often. What's probably more useful in this case is average speed because we don't have to take direction into account, and so you can say, you know, her average speed was 5.75 kilometers per hour.